Have all.
Ba-dum, ba-dum. Oh, I did this before. Minimum operations to exceed threshold. Yo, yo, what's up? Holy shit! I noticed I wear the same fucking white shirt every day. This probably is a contest problem, right? If I solved it before, wait, let's see when I solved this. March 2nd, 2024. Oh, do you have multiple white t-shirt? You don't shower. Do you think I shower? That's crazy. What the fuck? Out your back from doing all the sex, though? Still working? Well, no holiday for Zon. No holiday for Zon. Wait, don't you just fucking sort this? Wait, don't you just put it in a priority queue? Nice. Make stomp go up. Wait, what the fuck is Monday? Let's see. Monday, Feb 17. President's Day. President's Day. What is that? Federal banking holiday. That means the market's not open. Bro, I have a doctor's appointment on that day. What the fuck? Oh shit, I'm chilling. What the fuck? I have work? That's bullshit. That's bullshit. Another 500? I don't know. It's a follow up. Who cares? While PQ's not empty and PQ dot size greater than 2, greater than 1. You see, I haven't been at doctors in like 5 years. I did some labs and they're like, it's not that good. Wait, you and Bobby should collab contest virtual? Bobby said he could stream offline. I mean, grind offline like a. I mean, it's midnight over there. You haven't been a doctor in 5. Okay, I went in 2020. Yeah, I went in 2020, like right after COVID. So they're like, your shit's kind of high, but I'm like, it's the same shit as last time. Who gives a fuck? And they're like, we should look on it. It's all down tomorrow on the weekend. What the fuck? Wait, do you have a day off on Monday? Wait, Bobby, you don't get the U.S. holidays, right? Because Canada is different. Yeah, no, it's an actual holiday in the U.S. Canada don't get shit, right? Whole different country, unless you're the 51st state. Okay, you pop these two out, and then you add C equals math.min AB times 2 plus math.max AB. PQ.add C. If peak PQ.peak is greater equal to K, break. Or B is greater equal to K, break. Return min op. Juice with the raid. Yo, that's good. What the fuck is that while loop condition? If it's greater than 1, right? Like, why not? Fuck. What first condition? Oh, this one. If size greater than 1 can't be in. I got no answer for that. I don't know. What the fuck? 7 to 7:15 Zoom from CEO. 7:30 Charlotte's email. In that email, if you get let go or if you survive. What the fuck? My friend is fucking. Yikes! 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 Group Jason? No, no, different friend. It's fucking Blue Origin. That's fucking some scary shit. Holy fuck. Um, Pop 2, add 1. Why is there only one? Okay, let's see. Case 45, you pop 24, 26. You add Is that it? Fuck. No! I'm retarded. Oh my god, I got long. Right? Wait, I got 3. Is that long? I fuck, we tried anyways. Long, man. Change everything to long, because fuck it, YOLO. Or you can combine line 12 and 9. Oh, you're talking about this. And PQ dot peak is greater or equal to K. Well, I fucking guess. Also, A is always small since top of the heat, right? B is the max, so no need minute max. Aren't you a fucking smart fuck, huh? What the fuck? I guess you're right. I guess you fucking right. Rico said that. I did like what you did. Pat Smart, time to relax. I'm fucking retarded. What are you talking about? What contest was this? More Abraham, say less. Let's go. Abraham time. See you guys. Well. Who the fuck's actually here? Who's still here? That's pretty good. Man, fucker. What? Oh shit, you're still here. That's crazy. Hello. This was the Q3 explanation, right? Hell, these nuts. Yeah, but he lost me for Q3. Bro, my handwriting's so nice. I stop jerking yourself off. Those are the hands you use to jerk yourself. Come on, relax. He uses this. The Wacom tablet, right? Am I right? Yeah, rich people moment, bro. It's like $40, right? If I could do this with a mouse, it'll be finger banging Superman. I don't know, right? Like, okay. S consisting of digits 0 to 9. Count pairs left to right. The substring of left of right plus 1 is divisible by the rightmost of the substring when left or the substring of left to r plus 1 and are treated as numbers. Such that, hey man, such that substring, this is a substring, no? Length S is 1e5. So linear or n log n, which means binary search or some fucking linear bullshit. It's for specific right, how many left and less than equal to right work. For digits in range 1 to 10. I would just watch your fucking VOD, but I can't watch because I'm not subbed. If you have stream over the weekend, I'd be going on your stream instead, but no. How to use a paywall channel? I mean, okay, I didn't stream Sunday. Yeah, you're right. Whoopsies. Literally paywall. I cannot watch it. I'm too cheap to sub. What can I say? How the fuck did I solve it? I got fucked by Long Long. Of course, I have not talked about incident involving two building and two plane or called Brent slur or talked about Gartic artists not living long and fulfilling life. But that's beside my point. I mean, it was funny. I don't know how they caught you. Fucking Automod. NCC reported me. That's crazy. We need the contest hero. Oh, that was a joke. I know, I know, I know. It's a joke. That's crazy. It'll be funny though. Happy Black Month. Just found out today. What's up, my neighbors? And when can I get the N word pass? What's up, my neighbors? For a specific R, how many left? Let me go to right. Work. For digits in range. Count left, right when S equals digits. For R in range 0, 1. Number something. For digits in range 1 to 10. For R in range 0 to. What the fuck is that? 0 to 9? What is that? That's a 9, right? N. Oh, fuck, I'm trolling. Something in O of 1 or log N. So that's where you fucking binary search. It would be 10 times N times log N. Not binary search? Sort? Some sort of sort. No? People still learn how to write in script. I'm just saying it could be O1 or log N to pass. In this problem, the inner block is O1. Really? Fuck. What is the value of mod D? The distance? There's some proof shit, isn't it? Bro, it's doing Snow's paywall. It's okay. Just give me just clip her paywall. You can clip, right? You can explain one more time. A better. Hold on. Let me pull up the contest question. This one. Hello.
Hello?
So,
Wait, am I echoing?
ooh, are you?
Oh, it's because I have your stream on probably. All right, give me a sec.
It's range 1 to 10.
Okay, I think I'm streaming, right?
Yeah. Yeah.
Okay, so uh okay, so just a quick overview, right, of what the strategy is. So the question is basically asking, right? You're given the string, whatever, right?
Yep.
It's counting LR such that the substring L from L to R plus 1 mod S of R equals 0.
equals to 0? Or
Yes,
is 0?
right? Because
Right,
they're
'cause-
saying that when this is treated as a number,
right. Okay.
right?
That's
Because
like
that's what it means to be divisible, right?
right.
This is the problem that we're trying to solve. So, you can imagine, right? Like the way that we're gonna do this, right, is first we're gonna iterate over the digits. Okay, so like we focus on a specific digit D, right?
Okay. Yeah.
First. And then once we choose which digit D to focus on, right? Then we're trying to solve the following problem, right? So you have this right pointer, right? And you want to know inside, like how many. So here you want to know like how many left pointers work, right? That satisfies this condition. Does that make sense? So the reason why we do this, right, is because it's very easy to get this condition, right? All you have to do is like here to get this condition here, all you need to do is if like SR does not equal D, just skip it. Or like don't update your answer. Don't update result,
Okay.
right? Because if you just iterate over all of the digits, right, from 0 to 9, as long as you skip over the ones where S of R is not actually equal to the digit that you currently expect, and you don't update the answer, like the final answer you get if you iterate over all the digits D is like exactly this value, right? Because like for the places where this S of R is not equal to the digit that you're currently focused on, it just doesn't contribute anything to the answer, right? So the final thing you get in result is just only for each index, right, R, it's only updating the answer when it actually matches the
Right.
digit that you're focused on.
Because that's
So,
the
I'll
rightmost.
actually pull out the code
That
like
should be the
earlier this
rightmost,
time.
right? Because that's the rightmost digit. Like this.
Yeah,
D.
R is the right pointer.
Yeah.
Yeah.
Okay.
So we can just go through like the code bit by bit.
Wait, what? Oh, there we
Okay.
go.
So like that's what this outer loop is doing, basically.
Yeah, it's 1 to 10 or 1 to 9.
Yeah, 9, right?
Yeah.
Where 10 is exclusive because that's not a digit.
Right.
But this outer loop, right? And then here, right, you see whenever I update my result, I'm only like you still need to do other stuff, right? Because you need to like maintain some state at
Mhm.
each index, but you only update your result if the current digit that you're on is equal to the digit that you're focused on.
Right. Otherwise, it doesn't matter because
Yeah.
it.
Otherwise you still like as you can see, we're still doing other stuff here, right? But the important thing is that you just don't update the result, right? Because the ending number is incorrect,
Okay.
right?
Yeah.
So by doing this, you're basically focused on a specific digit at a time, and you like it's like very easy to like actually use this fact and still maintain like the correct answer. Okay.
Okay.
So that's like the first simplification. It's just realizing you can do this for one digit at a time. So now, like,
How the fuck
whenever
do I
you see
see
a
that?
problem like this, right, the first thing you should be thinking of is like, you know, how do I express S from L to R plus 1 as a number, right? Because right now it's just a substring, right?
Yeah.
And you need to be careful here because the difficulty with these substring problems is that like the substrings can get very large, right?
Yeah.
As when you're at index R, there's a ton of substrings. Like for every single left value, that's a substring, right? And each substring itself can be O of the entire O of n, right? O of the entire length of the string. You
Right.
need to find a better representation for this. So the first thing to realize, right, is that you actually just need so like let's think about how to represent this as a number, right? So the first thing you should notice, right, is that we only care about s from L to R plus 1 mod d, right? Because that's the actual value you're caring about, right? You don't care about the entire value. In fact, the entire value could be really large, right? Like if the string was length 10 to the 5, then your substring can also be length like 10 to the 5. That's a lot of memory. It'll TLE for sure, right?
Yeah.
But you only care about like this value mod d, right? Which means that actually, this is very small, right? Because this is just like a single number from like between 0 and 9, right?
Right.
Because d is a digit, so when you take something mod a digit, it's just going to be. I'll be even more clear. 0 and d minus 1, right? When you take a number mod d, you get a number from 0 to d minus 1.
Yeah, that makes sense.
Does that make sense? So it's like very like the first thing you notice is that like the state that we care about is actually very small. It's just a single number, right?
Mm-hmm.
But still, like this is not a very this is not a very great way of doing this, right? Because remember, you need like when you're at a particular value of r, right? You need to do that like whatever work you do in this inner block, right? This has to be done in O of n or O of 1 for the like for a passable runtime, let's say. For this r is O of n, right? And everything, so it's going to be like O of n times whatever this thing inside is. So if it's linear, then you're fucked because you'll be O of n squared.
Yeah.
Sorry, that should say O of log n. So that's what I was trying to say in the notes, right? I'm not saying that this solution will be O of log n. It's just that in general, for this type of problem, your
Okay.
inner block needs to be O of log n or O of 1.
Right.
Does that make sense?
Because it's 10 to the 5, you can't do n squared. So, yeah, that makes sense.
Yeah, exactly. So we still need a better way to represent this, right? So the first idea, right, is like whenever you see a substring, right, you should be thinking about something like prefix sums, right? Because prefix sums lets you like compute something in O of n and have an O of 1 way of representing each substring, right? So can you use prefix sums to represent this value? And the answer is kind of, right? So let's say like you let, P of R, or I used M, so, or what did I use? Let's say we use like, A of R, let's say, or I think the actual array might be, let's just call it P of R
Sure.
equals the value of S from 0 to R plus 1 mod D, right? So you can compute this array P of R really like in a pretty simple way just by like you just keep track, like you should notice that P of R, right, is equal to P of R minus 1 times 10 plus S of R mod D. And the reasoning for that is like, let's say like let's say this is R and R minus 1, right? And this is R.
Okay.
Right? So like think about like let's say you've computed P of R minus 1 already, right? Let's mod D already. So this is already the value so far, right? And now you want to include this new digit at S of R, right?
Okay.
So what do you need to do? Well, think about how it would work for numbers. Like let's just ignore the mods for now, right? Let's think about if it was just for numbers, right? So like let's say, you know, your S array is equal to like, I don't know, 1, 2, 3, 4, right? So like at this index, right? Again, if we ignore the mods for a second, like P of R will be like 123 mod D, right?
Okay, yeah.
And then P of 4 or P of, sorry, this, I guess that should technically be this one. But then P of R will be equal to 1, 2, 3, 4 mod D, right?
Yeah, you
So notice
shifted
how you
over.
go from 1, 2, 3 to 1, 2, 3, 4.
Yep.
The first thing you do is you multiply 1, 2, 3 by 10, right? You need to shift it over by one place. And then you add the current digit, which is 4. Right?
Right.
Do you agree with this?
Yep, I see it. You times
So,
10
so
to shift it over
basically, by
1.
using this recurrence, right, you can compute P of R in O of 1, right?
Okay.
So now, okay, so we have the prefix sums, right? But now, like, let's think about again, how do we represent S of R plus 1 from L to R plus 1, right? Well, it gets a little bit complicated because it's not exactly prefix sums. Because in regular prefix sums, what you can do is you can just subtract, right? Like, you might be tempted to say, okay, like, is it, you know, is S of L to R plus 1, let's say, like, P of R minus P of L minus 1 mod D. And the reason why it's like this is because P of R includes the rth term, right? And you want to subtract everything to the left of L, so that's why you subtract off at L minus 1. This is just a little bit of like potential off by 1 errors, but this is correct. So you might be tempted to say like, okay, is this just how we get the value of S of L to R plus 1? It's just this quantity. Because this happens a lot when you use prefix sums, right? Like you've probably seen in a lot of other prefix problems where you just subtract, you know, the endpoint from the start point that you don't want,
Mm-hmm.
and that's like the value of the substring, right? Have you seen that? That's this trick
Yeah,
before?
that's the normal way of using prefix sum, right? That's the
Yes,
yeah.
right. Like you get the sum of a segment, right? But
Right.
here it doesn't quite work, right? Because let's again use this example, right? In this example, the answer we'll be expecting, right? Let's say, you know, again, let's say L is equal to 2, right? R is equal to 3, right?
Okay.
So S from L to R plus 1 mod D, we would expect this to be 4 mod D, right? Because if L is equal to 2 and R is equal to, sorry, if L is 3 and R is 3, then we would just expect it to be a single digit 4, right? 4 mod D.
Right.
Does that make sense? Like this is the correct understanding of the substring mod D, right?
Yeah.
But if we just use this difference, so this is the correct way, correct value, right? But if we try to use like this idea, right? Then what would we get? Well, we would say that it was, you know, 1, 2, 3, 4 mod D minus 1, 2, 3 mod D, right?
Yep.
But this is not correct, right? Because really, you should notice what you really want to subtract is you want to subtract 1, 2, 3, 0 mod D.
Ah, 1,
Right?
2, 3
Because when
times
you
10.
subtract this, you'll get the singular 4 remaining, right?
Okay.
Does that make sense?
Yeah, I see it. Because
So there's like this weird thing here, right? Because it's kind of like we do want to take the difference, but we do want to take the difference, but um, like it's we actually need to like this part is not correct, right? We should not be subtracting this value. We should actually be multiplying this by 10, right?
right.
But actually it's more than that, right? Because if we just took it, like if we did another quick thing, right? Like if L was like 2, right, it would be like 1, 2, 3, 4 mod D minus 1, 2, 0, 0 mod D, right? Because if L was equal to 2 and R was equal to 3, then this would be your subarray, right? The 3, 4,
Okay.
right?
Yeah.
So then you would want to take like what you would want to take the 12 and multiply it by 2 tens, right? Or like multiply it by 10 twice. Yeah. So
So how many times do you multiply by 10? Seems like that's the trend, right? So how do you figure that out?
okay, so all right. Okay, so that's like the substring, right? So basically there's this issue where it's not just the difference. And you can actually follow this pattern and realize that the actual value we want is we need to pad this by some number of powers of 10. And the actual amount that you need to pad it by, if you follow like this math real quick, it's just a difference plus 1. So like R minus L plus 1. Because for example here, you would want to multiply by 10 squared, right?
Yep.
And then in here, it's like 1, 2, 3 times 10 to the first, right? So R minus L is 0 here, plus 1 is 1. R minus L here is 1, plus 1 is 2, right? So this is like the actual formula, mod D. Okay, but the issue is, right, is like, how do we actually represent this, right? So if we could represent like this formula, like like this is basically kind of our main way of attacking this problem, right? Because again, we can calculate this value, right?
Right.
Which means that, remember, we want this thing to be equal to 0, right? This is what we want,
Yes.
right? When it's equal to 0. So if it's actually equal to 0, then we know that we would want like PR to be equal to P of L minus 1 times 10 to the R minus L plus 1 mod D, right? Because remember, P of R has already been modded, and I'm just like moving this term to the other side where there's a 0, like adding it on both sides. So we just want this value, right? Which means in particular that what we can rephrase this as, right, is we just want to count like how many values, like how many indices right? Because notice like when we're at R, right? Like this R is a constant, right? This D is a constant. So the only variable you have here is L,
Interesting.
right?
Yeah.
So basically you just want to know like this is like a quantity that's like well defined based on L, right? Like you could like with just the L value, you would know like what this is, right? But the difficulty is even though R is a constant, like it's still this quantity is still changing with respect to R, right? So it's like, how do you make updates with respect to the fact that like this R, you're incrementing over the R, right? There's like a for loop that contains uh the R. Where the fuck is yeah, there's a for loop here that contains the R, right?
Right.
So
That's weird.
you need a way to like sort of you're basically just trying to count this value, right? For each value of R, you want to know like, okay, how many previously seen values of L like satisfy this, like how do we count this value, right? So the idea here is, it's kind of tricky, right? It's basically like the way to think about it is like initially, right? You just need to think about like how to update, right? So let's say like we have this other array, which is like R of X is equal to, or did I think I might have called it, yeah, I called it R. So R of X is equal to the count of uh um how do I want to say this? So it's kind of like, it's basically like you're padding, you've already padded the extra tens, right? Um, so I guess it's like the count of P L minus 1 times 10 to the R minus L plus 1 mod D equal to X. Right? You're counting like how many count of like L, I guess. You're counting how, like this is what we're trying to count, right? We're trying to count how many L's values satisfy the fact that this thing is equal to X. So we need to keep track of like basically like, you know, the X here is just a value from 0 to D,
Okay.
right? And you're saying like, okay, we want to we just want to keep track of like all potential values, right? Like this is like, remember this is kind of like, you know, the value of some prefix like added with um with zeros, right?
Yes.
That's sort of what this value is. It's actually like it's basically the idea that, you know, you want to keep like all of the prefixes, right? Because again, like if we go back to here, right? We're trying to kind of take the difference, but as you see, this is not correct, right? We're trying to take the difference where the prefix has been padded with this uh like power of 10, right? There's like there's some extra powers of tens, right? And in fact, like what are all like any, you want to keep track of like all possible values of L, right? So really what's happening is in this 1, 2, 3, 4 case, right? Like if we go back here, maybe it'll be helpful to like write this out, right? So in the 1, 2, 3, 4 case, right? Let's say, you know, R is equal to 0, 1, 2, 3, right?
Yep. Yep.
And this is the S array, right? So the value, like when you're here, the prefix of L minus 1 times 10 to the R minus L plus 1, right? What are these values? Well, those are just the values of, so first of all, you could have just taken no numbers, right? So it's all zeros, but it's been padded with the extra zeros at the end, which I'm writing out. Or, right, you could have stopped at the 1, right, and taken this 2, 3, 4. So what does that look like if you're at index at R equals 3? Well, you would want to have the 1 here, right, and pad it with 3 zeros, right? Because that way, again, when you do like 1, 2, 3, 4, subtracted this, you're left with 2, 3, 4. Does that make sense?
Yeah.
Or I mean, I can tell that like I might be losing. So the point I'm trying to make, right, is like from 1, 2, 3, 4, right? There's a couple of substrings you can have, right? You can have 1, 2, 3, 4. You can have 2, 3, 4. You can have 3, 4, and you could just have 4, right?
Okay. Yep.
These are all the substrings that that ends at R equals 3, right? So how do we make these substrings? Well, this is equal to 1, 2, 3, 4 minus 0, right? This is equal to 1, 2, 3, 4 minus 1000, right?
Yep.
This is equal to 1, 2, 3, 4 minus 1200, and this is equal to 1, 2, 3, 4 minus 1, 2, 3, 0, right?
Yeah.
So if we want to keep track of these differences, right, it means that we want to keep these numbers, right? These numbers need to be kept. Need to keep track of these numbers, right? Because you want to know, like, you know, if this difference is equal to 0 mod d, then you want to keep track of like what these numbers are, right? And to demonstrate this a little bit more, right? When not only do you need to keep track of these numbers, right? When you move to one more digit, right? Like for example, if it was 1, 2, 3, 4, 5, right? You basically need to keep track of all of these numbers with an additional 0.
Yeah, it's all
right?
of them with an extra thing at the end because you
Yeah, so
shifted
you would still
everything.
have
Right.
0, right?
Yep.
Because that's always 0. Or you could have 1 with 4 zeros, or 1, 2, 3, or sorry, 1, 2 with 3 zeros, 1, 2, 3 with 2 zeros, 1, 2, 3, 4, 1, 0. And that's it, right? If your number was 1, 2, 3, 4, 5, when you move to like the next index of R. So you need to keep track of like these values, and you also need to be able to do basically perform the operation where you multiply all of them by 10, right? Because that's what we're doing here, right?
Yeah.
Because so like if you could, so the idea is, right, like with what we said about this R of x is just a like R of x is a frequency map. Because again, the crucial thing we need to know is we need to count how many there are, right? Because remember, this 1, 2, 3, 4 will be taken mod d. All of these numbers will be taken mod d, and we just want them to be equal, right? For each of these numbers, mod d, that's equal to, 1, 2, 3, 4 mod d. That's a valid solution, right? So if we keep a frequency map, right, for this x, right, if we just plug in p of r, right, that would tell us exactly how many values in the prefix are equal. So like, r of p of r is equal to the number of L values, or number of values for L, such that S of L is 1 mod p equals 0. Because, right, like this, it's because of these subtractions, right? Like for each of these prefix values, right? If that prefix value mod d is equal to the entire string, like the entire prefix so far, mod d, that's a valid solution, right? Because when you subtract those two, you'll get 0 mod d, which is exactly the substrings that you want. So this R of x thing, right? So hopefully you understood what P of R is, right? Which is just like, you just keep a prefix, like mod d for the numbers.
Right.
This R of x is like kind of a frequency of these values, right? Which is the P of R values padded by extra powers of 10, right? So like, for example, here, you would take all of these values mod d and put them in a frequency map. So if we do this really quickly, right, let's say as an example, right, if e is equal to 3, right, then R of 0 will be equal to 3, because this one, and this one are all 0 mod 3, and R of 1 will be equal to 1, because this number is 1 mod 3. And there's like a divisibility rule for mod 3, which is why I'm able to do this quickly, but you don't have to worry about that. I'm just giving an
Okay. Okay.
Yeah, so basically you can just assume that that's correct, and that this is like the values of R, right? And all I've done is I've taken all of these values mod 3, and I just increment the corresponding index in my R array, which is like the frequency map. Okay.
Okay.
So if this is true, right? And let's say, like right now, P of R is equal to, let's say it's equal to 0, right?
Okay.
Which means that the prefix, if P of R is equal to 0, right, then that means like the padded prefix, we can subtract is also
0.
0 mod D, right?
Oh, 0 mod.
Because, again, because of this relationship, right? Here.
Yeah.
You need the current value, which is P of R, that's the current prefix mod D, minus this padded prefix mod D. They have to be equal, right? So here, the padded, if P of R is equal to 0, right, then the padded prefix you can subtract is also 0, like mod D, right? So what you would do is you would go to the corresponding lookup, R, right, and you would see, well, R of 0 is equal to 3. There are 3 of these values, right? And those 3 values are, this is 0, this 1, 2, and this 1, 2, 3. So, but okay, so this example is a little bad because 4 is not equal to 4 is not like the ending digit needs to be like, because we took D is equal to 3, right?
Right.
The ending digit is not divisible by 3 here, so here it actually wouldn't count. Because yeah, like this outer
Yeah, the outer loop wouldn't count, but the
yes. But the state would still update, right? So here,
Yes.
like the result wouldn't get updated because there was technically a 4 here. So if we quickly changed it into a 3, right, then you would be able to see that like all of these, like P would be divisible by 3,
Mhm.
P of R, and then there wouldn't be exactly 3 values that work, right? Like this value would work, this value would work. Sorry, no, this value will work, this value will work, and this value will work because they'll each leave a remainder that's divisible by 3. But this one would not work because you would have like 2, 3, 3 left. And again, I'm just pretend it's not a 4 here, it's a 3, so that
Yeah.
this gets counted. This is not divisible by 3, so it does not work. But like 1, 2, 3, 3, which is what you would get from this first choice. 3, 3, and 3, these are all fine, right? So you would get that there are 3 working answers here.
Yeah, I see
So
that.
the main idea is like, how do you keep track of these values, right? And it's actually, so like you can just try working with this R array directly instead of thinking about all this padding stuff, right? Because the idea is, right, like if like let's say R, if your R array is correct at like R equals 0, right?
Mhm.
And you can shift it to like R plus 1 correctly, then it'll work for all of them, right? Because it's correct at R equals 0. If you can shift it, if you have some way of making it work for R plus 1, then it's going to be able to work for your entire array. And the way, so like the idea is basically like, how do I transition, right? Because initially, right, R is just equal to the array, like, again, if we use the example D equals 0, it will be equal to the array 1, 0, 0, right? Because the only thing you have is the completely empty prefix, right? Which always has a mod of 0. So there's a 1 in the 0th location
Mhm.
and a 0 everywhere else, right?
Right.
So how do we like update it? Well, the main thing to realize is that how like what are we actually doing with each of these numbers, right? Remember, this is just a count, right? But how do the indices map to each other? Well, for each of these indices, right, what's going to happen is you're just trying to multiply by another power of 10, right? For each of the things that are currently in your R array, you just need to multiply them by an extra power of 10 to like pad it with that one extra zero, right? Because as you can see here, to go from like R equals 3 to R equals 4, all you're doing is you're multiplying all of the numbers that you've seen by 10.
Right.
Right?
Yeah.
So basically, to go from like, R sub R of X, right? Where does this map to? Well, it'll map to R of R plus 1 of 10 times X mod D. Because, right, remember, this is just a frequency count, right? This tells you how many values that's equal to this like mod that has a mod equal to X there are, right?
Okay.
So when you shift it to the next index, right, all of these counts, what do they get mapped to? Well, all of those values of X, right, they'll just get an extra 10 multiplied by them and then modded by D again. So if you just make this mapping to move it to the next R array, right, then it's going to be correct the entire way through. So here you can take a quick look at what we do here. So we have the R array, right? Initially it's all 0. The first thing you do is you add 1 to the 0 to the mod 0 mod D index, right? Because the empty prefix always is a possible choice. That's where you just take the entire, if we're speaking in terms of R, right? That's where you take like the entire array up to R, right? So you always have the empty prefix as a thing to subtract.
Right.
And the first thing you do is you need to pad by an extra power of 10, right? So what you do is you first create a temporary array, which is all zeros. And then, right, so this R is currently the previous version of the frequency map, right? So what does R of J get mapped to? Or R of X get mapped to? It gets mapped to X times 10 mod D, right? And the important thing to realize is like you're adding them to this, right? Because it's possible to have multiple different values of J mapped to like the same one of these values. So you need to increment them, right? There's a mapping where, like if these are your X values, right? And these are your X values for, R of R plus 1. This is your X values for R of R. It's possible that multiple of them get mapped to the same index, right? So that's why you start with a blank index for this first, and then you add everything in, right? Like it's possible that something no longer gets mapped to at all, and something gets multiple of them mapped in. So you start off with a blank one, and you plus equal instead of just setting. You need to like take into account that many things can map to the same index. This temp is really the new R array, right? And after you're done with this process, temp is kind of your new R, so you can just swap them, right? You still want R to be, the current frequency map.
Right, because it becomes a new current. The temp is a new current. Yeah.
So P, right? This is the running prefix mod D so far. So you update P, right, by multiplying by 10, adding the new digit, and taking a mod D. And then you know that the key that you're looking for, right? So first, you need to make sure that the last digit actually agrees. And if it does agree, right, then you know the number of answers is exactly the frequency of how many times like P has appeared mod D in your R array. So you just increment it then, but only if the last digit agrees, right?
Yeah.
And the final thing you do, right, is if we take a look here, right? When we're at R equals 4, right? We didn't have 1, 2, 3, 4 in our R array, right? Because we haven't seen the 4 yet. So, that's why we only had 0, 1, 1, 2, 1, 2, 3, right? There's no 1, 2, 3, 4 because we haven't seen the 4th index yet. But when you move into the next index, right? This is now a valid value, right? Notice there are 5 things here, right? But only 4 things here.
Yeah.
And the reasoning for that is because after you processed this R equals 3 index, right? That's now a valid prefix to be removed from, right? Because you need this 1, 2, 3, 4, 0 to be able to get just this subarray, right?
Right.
So the final thing you do is you increment R of P, right? Because that's the current value. So like basically after you process 1, 2, 3, 4, you put 1, 2, 3, 4 into your R map, right?
Okay. Yeah.
And then at the next step, right? So like before, like when we hit like this part, before we do anything else, right? We actually don't have these extra zeros, right? When we do this step, that's when we put the extra zeros back, right? So now, like basically when you added it in over like at the end of the previous iteration of the loop,
Okay.
like at here, line 21, right? You're adding in 1, 2, 3, 4, right? And
Yeah.
then in the next iteration of the loop, right? And the way your map looked like was like none of these zeros actually existed, the trailing zeros.
Mm-hmm.
And then at the start of the next iteration, that's when everything gets multiplied by 10. And this is now the correct state for R equals 4, right? The index 4.
Right. Because that's the
Yep.
last
And
substring you have to account for. Or
yeah.
yeah.
So you need to like make sure that your for loop is like updating the state at the correct places correctly. Because like you can't do this just like willy-nilly, right? Like you need to be able to do this at the start here, to get everything into the correct state before you add to the answer, right? Because if you do this later, then this R array would be wrong, right?
Right. It'll
So
be
that's
different.
just
It'll
something
be
to be
changed.
careful of.
Right. Yeah.
All right, I'm gonna be in the chat, but I gotta hop off.
All right.
But I'll be in the chat. If you have any questions, just type it out there
Okay.
or say it.
Sure.
Cool.
Thanks.
Yep.
All right. Let's implement this. How do you do a swap in Java? Is it just copy? We'll get to it. Res equal to 0. And then we want to count through each 1 through 10. Well, 1 through 9. But then we're counting from here. We're trying to go through n. So j equals j is less than s dot length. It's plus. And you're talking about p times padded. How do you can't make a list, right? Because you need to. R is this one that equals a 0. As we were going through this one, it's only for each one you increase the padding inside here. Level 10. Okay. So for each one, we take the character and get just some. He's actually outside. You see on link for this task? Sure, it's this problem here. Oh, because we want to create the new temporary inside here as we move forward. But where? I think this one's on the outside. Yo, what's up? That's good. But we want to keep track of the padded stuff. That's the R. This is the current R. So it's like R zero. Oh shit. So do you feel like you've been improving lately? I barely be streaming. What are you talking about? Sorry, I don't overact. I was Madge. Apologies, I don't hate you. You're addressing the Sudoku notes. No, because P is the one. No, no, that's right. That's right. Something like that. Long equals 0. Currently is long P equals 0. It's okay. I was a dick. I was just reliving the high school life where I was trolling people out getting tested by a teacher. The fuck? J would be the right because we're keeping track the right, which is this. So for each digit 1 to 10, we create an array R. No, fuck, I can't call it R. What can I call it? It was the big R. Fuck, array R. And for each of the rightmost, or non-rightmost, fucking digit, we create a temporary array temporary array 10. This one's where we fucking for each j equals 0, j is less than digit is I, j plus plus temp something mod digit is I. It was like array R J times 10 mod I plus was array R J, because you want to most shift this by 10 mod digit parentheses some fucking shit. This one's where we create a new thing times 10 and you add it on. That's the thing where we do the shifty. Fuck, where is it? The shifting. But the new one was better. Do you have the new one? The new Excalibur? Can you link that? No. 0 to 10. 0 is 1. Each one. Do a little shifty. Oh, fuck. I didn't add the... Fuck. S.char J. And then you have to convert that to a number. Integer dot parse int. Fuck, I'm retarded. I'm not taking a number yet. Where do I take the number? Digits I. A times D, right? Redo. This is the fucking letter you do at the end. And after all this shit, you mod I. Something mod D here. I don't fucking. Something mod D. Which is something times 10 mod D. Just J. We're counting up to I. But yeah, I think it's just J. But here's the number you add at the end. You want to take the current number times 10. Current number times 10 plus, yeah, current long times 10 mod D. So for 1 to 10, whatever, for each array equals 0 equals 1, long P equals 0, initialize P, so for a while, R equals 0, R is less than 1, or less than length, plus, so for each new temp, we create a new array here where it's new array here where it's so fucking dumb that added rule for 0 is just busy work. Here, so What do I? It was brand new long. First one 0. Makes sense because it's the whole thing. Go through the whole array here, the whole string here. This is the weird part. Is it this? Could you create a, you want to shift one over every time, mod D, because the weird mapping thing. So because you do the weird mapping thing, J shift over by 1, so fucking what? See, that was the part I was kind of weird, but I guess I know you add this because you shift everything over. Oh fuck! So just add this mod D, or is it mod? Might be modding D here because P equals 0, P times 10. P is the running counter or shit. But does it get too long? On 10 and a 5. Goes to D. Fuck, not R. It's fucking the current value. Or at 0 equals to D. Then you add that. But because this is the new temp, how do I array R equals temp? Where do I populate? Each 0, 1. This. Brand new one. You want to shift this over. Then you want to set your new array. The reason why you can't have this array because the mapping issue. So you create a temporary new brand new array and then you map it for each thing up to digit. I guess not I. Up to digit. Set that. And P should equal to, is it P times 10? Fuck. We want the whole thing. But it was like the left. How the fuck do we get the left? It was like P. D. AR. Remember he moved it down here, but I forgot why. I was trying to visualize it by reading this shit. This should be here, 2. Every time I reach 2, put the current one 2. So it's like 12 mod 2 works. 2 mod 2 works. And the previous 1 mod 1 works. That's why the current is 3. Because it was p times 10 plus the current digit, or not digit, of the thing, then you mod that by d, because you only care about I fucking resend it. Oh fuck. Somehow worked. Was it J? Still was J. It's fucking weird. Yeah, this bar is still fucking with me though. Because J mod times 10 mod D. That you take is just like 0 times 10, 0 still 0. Mod D is the number, is the current digit you're on. But why does that mapping have to move? Yeah, that one. This is some fuckery question, bro. I could never come up with this. It was like you took the fucking prefix and said, fuck the prefix. You could recalculate everything. How do you intuitively figure this out? It's just because it's a fucking substring problem. So you're like, oh, substring, the prefix might work. Well, Pat, it's fucking troll. To be fair, Metsup gave me the fucking answer. He was just like, he explained it. I was trying to remember. How the fuck did you figure out the mod part? Prefix mod part. That's fuckery. There's no way you can think of that, right? Like this right here. And then you mod D, and then you're like, oh. That's impossible to figure out. What the fuck? Well, when you drew it out, it kind of made sense, though. So you gotta, like, the only keeping track of like 1, 2, 3, 4, and then your fucking R, X, or whatever is keeping track of 0. Like 10, 12, and 1, 12, 0, 0, 1, 2, 3, 0. Okay, I understand. It's very different. The fuck? How would you have solved this? What? That's weird. Because that's the fuckery part. But then all this mod D. How the fuck would you figure that out? How? That's the fuckery. I would have kept track of all the string and at position I. And would add or return or 0. Because 0 mod the digit. Right. Okay. Then my transition would be okay. RET plus equals R0. Sure. Temp J times N plus S I minus 0. I mean D plus equals temp J. Would it be RJ or something? R0? How would you keep track of? Yeah. Kept track all the string that end at position I. So like a position 0 is fucking 1. Position 1 is like what? 1. Well, 12. 2. Yeah, I see it. It would be 2, 9, 12. Oh shit. 29, 9. You can see how we multiply 10. Yep. Interesting. That temp is exactly the same. So it's like slightly different. Because this one does it for all digits. Then you go through. Yours would have been go through the whole string with each one keeping track of string. This formula is exactly the same. That's still some mind fuckery. How the fuck do you guys think of that? What the fuck? There's a DP way? What the fuck? Who's the fucking GPT way? What the fuck? This is a DP way. It's just we take out the. That's pretty pog. Wait, let me refund your goss. When are we restarting past journey? Okay, I took the EKG. I'm good to go. But I'm still seeing a cardiologist in like 2 weeks. Oh, past journey. Might have to start now. Alright. The question becomes, do I stream the workouts on here? Because I also have a twitch.tv/past journey. But that's fucking troll. It's fucking dead. It's German Pass Hello World. Alright, what kind of workouts do I stream? Not the Sean T shit, right? Oh, the doctor said go just in case. Just to check. Oh, yep. Your leak solution? Now start with crutches. Or size. For the rain digits. Reach Jane digit. With this. Plus CD plus. DP equals NDP. Now start a crush, then go biking, machines at the gym, then jog afterward. Four. It's like 4% right now. Like doing Lico how to write for it. Fair. You made it up here, right? The CD, which is the current digit mod digit plus plus. The DP is the outside vector array. Interesting. That is different. Well, kind of. I can notarize C++ about my preamble. Wait, what's the difference between rep and for? For and I equals from. Oh, from. Okay, I'm trolling. Well, it's easier for me to think like this because you don't have to think about subtraction. Because you're building up to the digit, right? Instead. And then you're keeping track of Fuck, I'm trolling. Because this one is. Yeah, because you always have to have an array. Exactly, all the strings ending at I. Palm 4 is bad for Python users? Really? Damn. Interesting. Same code easily passes in C++ / Java. Damn. What was Q4? This one? Maximize the minimum game score. Let's try it your way then. Still D. I'm surprised at how people AK. On what? 4? Where the GPTers at? Four and 3? Really? Hmm. What was this one other than what I said above? Really? The fucking edge of passing shit. There's like 50 people in the queue to get to 4. Hmm. UTP times J mod D plus equals to UTP J. Here is the part where you do it slightly differently. You just DP. Need DP. CD mod D plus plus. And if CD mod D equals to what's CD mod D? Oh, CD equals to D. where you increase the CD mod D equals to 0. Oh, I forgot. CD equals to D. I'm fucking trolling. I had it right. CD equals to D. DPCD. Then you're gonna be like, I think we don't add the first digit somewhere. No? Fuck. Trolling. DP0. Yeah, transition is slightly different. Oh, here. Plus CD. Like that? Whoa, that's fucking weird. So let's say it's one plus two. So it's like 0 times, okay, 1 times 10, 100 plus 2. It's 102 mod. Fuck, whatever. Ooh, interesting, interesting. What else is DP should be always empty. I'll print it anyways, fuck it. Print NDP after you add DPs. So for each digit one, no mods there. Digit 2 should be the second one. So here we should have a res somewhere. Increased at the first. Second. Okay. Increase by 2 because interesting. Digit 3. 3 is the weird one. 129. Well, 3 is 1, 3 here. So I guess 1293. So you start at the first digit, the 1 gets turned. Mm, 239. 93. So that work? Yeah. That work? Yes. That work? Yes. That work? Yes. It's plus 3. Ooh. Can you go through the rest of the 6 here? That's some fuckery. Still weird to play in my head though. So was Q4 easier than Q3 or like for this contest? Wow. Huh. I don't think lots of people didn't solve. Oh. People just skip Q3. Holy shit. The Java master. Wait. He did it the same way you did it. What the fuck? Legit the same way. You and Yui. UWI. Holy shit, the exact same way. We did it in 3 minutes. Jesus. What the fuck? 2 minutes. Because 3 minutes of a second from 2 minutes of Q3. And 5 minutes for Q1. What the fuck? Like the only difference is like we swapped it up there. What the fuck? Yeah, it's GPT, right? Holy shit, they really wrote out all the fucking. What the fuck? Hmm. If you look at something, he'll think you look at his solution, not mine. Wait, you're right. Is it because Java? Did you guys literally have? It's fucking Java. Oh, is it time to go fucking sleep? I guess so. When's the time to bring back past journey though? That's a good question. Fuck. All right, who's streaming right now? Cereal for every meal. No leak coders? That's crazy. Y'all dead? Oh, how you just raid e-girl? Sorry, can't do that. Right, it's sleepy time, guys. Wait, why are you awake? Isn't it like 2:40 over there? I didn't know there's so many Twitch ego. What do you mean? Hey, you're welcome. You're getting exposed to e-girls. Look at all of them. Sup, Caitlyn? Whoever this girl is. All right, it's time to go take a nap. Wake up in like 7 hours. No contest, right? I totally didn't do this on a second account. All right. I'm gonna call it here then. Holy shit. Trying to learn something. Your way? Best Sims way? Yeah, I gotta figure out how to do this. Is there like similar poems? What the fuck is this? March 18th? Goddamn. All right. Guess me, Dej. See you guys.